Hello gardeners, welcome to the Living Soil Lab. What if I told you the secret to a thriving garden isn't just what you plant above ground, but what you bury beneath it? The transformation happening in my soil after burying Phacelia and buckwheat has been nothing short of remarkable, and I'm about to pull back the curtain on this underground revolution that's been quietly unfolding beneath our feet. Several months ago, I planted a dedicated plot of Phacelia and buckwheat with one singular purpose in mind: to bury them at their peak and allow them to work their magic beneath the surface. Today marks the moment of truth, the great unearthing that will reveal whether this experiment in green manure management has delivered on its promises. Standing at the edge of this plot, shovel in hand, there's an undeniable sense of anticipation. This isn't just about digging up some decomposed plant matter. It's about witnessing firsthand how nature transforms living tissue into the foundation of future abundance. The Phacelia, with its delicate purple blooms that once attracted countless pollinators, and the buckwheat, standing tall with its heart-shaped leaves and white flowers, were incorporated into the soil at precisely the right moment when their biomass was at its peak, but before they set seed. This timing is crucial because it captures the plants when they're packed with nutrients and their tissues are still soft enough to decompose relatively quickly. The question that's been burning in my mind for months is simple yet profound. What really happened beneath the surface during this transformative period? As the shovel breaks through the top layer of soil, the first thing that strikes you is how different this earth feels compared to untreated ground. There's a softness, a friability that speaks volumes about structural change. The soil crumbles in your hands rather than clumping into hard, compacted chunks. This is our first tangible evidence that something extraordinary has occurred. Carefully excavating deeper, we begin to encounter the remnants of what were once robust plants, now in various stages of decomposition, their cellular structure breaking down and merging with the surrounding soil matrix. The root systems tell an incredible story of their own. Phacelia's fibrous roots created an intricate network that penetrated deep into the subsoil, reaching down to access nutrients and moisture that shallow-rooted crops could never touch. Buckwheat's taproot drove even deeper, breaking up compacted layers and creating channels that will serve as highways for water infiltration and future root exploration. These roots didn't just occupy space, they actively restructured the soil's architecture. As they grew, they exuded substances that stimulated microbial activity and helped bind soil particles together into stable aggregates. Now, in their decomposition, they're leaving behind a legacy of pathways and pore spaces that dramatically improve soil structure. The wildlife activity in this treated section is immediately apparent and genuinely exciting. Earthworms are everywhere, far more abundant than in adjacent untreated areas. These ecosystem engineers are feasting on the decomposing plant material, processing it through their digestive systems, and converting it into nutrient-rich castings. Each worm we encounter is evidence that we've created an environment that supports the very creatures that will continue improving our soil long after this initial incorporation. Beyond earthworms, we're seeing increased populations of other beneficial organisms, springtails, beetles, and countless microscopic life forms that comprise the invisible but essential workforce of healthy soil. The decomposition process unfolding in this plot represents one of nature's most elegant recycling systems. When we buried these green manures, we essentially created an all-you-can-eat buffet for the soil microbiome. Bacteria and fungi immediately began colonizing the plant tissues, secreting enzymes that break down complex organic compounds into simpler forms. This microbial feast isn't just about breaking down organic matter, it's about transformation. The carbon, nitrogen, phosphorus, and countless other nutrients locked within the plant tissues are being systematically released and converted into forms that future crops can readily absorb and utilize. The nutrient release from green manures happens on a timeline that perfectly complements plant growth cycles. Unlike synthetic fertilizers that dump massive quantities of nutrients into the soil all at once, often leading to leaching and environmental problems, decomposing green manures release their nutritional treasure slowly and steadily. The Phacelia and buckwheat we buried contained significant amounts of nitrogen, particularly the Phacelia, which as a member of the borage family is relatively nutrient-dense. As these plants decompose, they're creating a sustained release fertilizer that will feed our next crops throughout their entire growing season. This gradual nutrient availability matches how plants actually take up nutrition, preventing waste and ensuring that what we've added to the soil actually benefits our garden rather than washing away with the first heavy rain. Perhaps the most significant contribution these buried green manures make is to our soil's organic matter content. Organic matter is the currency of soil fertility, the foundation upon which all other soil health parameters depend. When we added these plants to our soil, we dramatically increased the organic matter percentage, and this boost has cascading effects throughout the entire soil ecosystem. Higher organic matter means better water retention, improved nutrient holding capacity, enhanced soil structure, and increased biological activity. It's the difference between soil that's merely a growing medium and soil that's truly alive, teeming with the biodiversity that makes vigorous plant growth possible. The visual comparison between this treated soil and the control section I maintain nearby is striking and scientifically instructive. The untreated soil, while not poor quality, has a tighter structure with less visible pore space. When you break apart a clump, it fractures along planes of weakness rather than crumbling into the granular aggregates we see in the green manure section. These aggregates, formed through the combination of organic matter, microbial byproducts, and root exudates, are the hallmark of excellent soil structure. They create the perfect balance between water retention and drainage, between air-filled pore space and moisture storage, between stability and workability. The water retention test provides concrete evidence of improvement that every gardener can appreciate. Taking identical volumes of treated and untreated soil, I saturate both samples and then allow them to drain naturally. The green manure amended soil holds significantly more water while still draining freely, avoiding the waterlogged conditions that suffocate roots and promote disease. This enhanced water holding capacity means that during dry spells, plants growing in this improved soil will have access to moisture reserves that give them resilience against drought stress. In our changing climate, where weather patterns are becoming increasingly unpredictable, this buffering capacity could mean the difference between a thriving garden and a struggling one. Looking forward, these immediate improvements are just the beginning of a long-term transformation. The organic matter we've added will continue to decompose over the coming years, providing sustained fertility benefits far beyond the next growing season. The improved soil structure will make future cultivation easier, reducing the physical labor required to prepare seedbeds and incorporate amendments. The enhanced biological activity will create a more disease-suppressive environment, as beneficial microorganisms outcompete pathogens and produce compounds that protect plant roots. The investment we made by growing and burying these green manures isn't just about next year's tomatoes. It's about building soil capital that will pay dividends for decades to come. The transformation I've witnessed in this plot is entirely achievable in your own garden, regardless of its size or current condition. Green manures represent one of the most powerful tools available to home gardeners for improving soil health, and October is an ideal time to get started with winter varieties. Consider dedicating a section of your garden to Phacelia, buckwheat, or other green manure crops during periods when beds would otherwise sit empty. The investment of time and seeds is minimal compared to the profound improvements you'll see in soil structure, fertility, and biological activity. If you're inspired to transform your own soil and want to continue learning about regenerative gardening practices that actually work, subscribe to the Living Soil Lab. We're building a community of gardeners who understand that healthy soil is the foundation of abundant harvests and environmental stewardship. Share this video with fellow gardeners who might benefit from discovering the underground revolution that green manures can spark in their own plots. Together, we're not just growing plants, we're cultivating living soil that will nourish generations to come.